9.6b, we are continuing with our inverse trig functions, trying to find the angle that is given to us. So solving a triangle, first we find all the angle measures. And then all of the side lengths. For example, here we have this triangle. We want to find the angles. The angles would be, first we want to find angle measure. We know C, that's 90 degrees for sure. But we want to find the angle then of A, measure angle B. And then once we are done with that, we can find our sides. We can find AC, CB, and AB. We want to use everything that we have. We're going to have everything together. So how to find a side of a right triangle? I know that two sides, if we have two sides, we want to use the Pythagorean theorem. And that is, for example, if I had a triangle and it was 3 and 4, we use the Pythagorean theorem. We can find that. Remember, we use a squared plus b squared equals c squared. This being a, b, and c being our hypotenuse. Number 2, I know a side length and a measure of an acute angle. So if I know a side length and a measure of acute angle, so let's say if I draw a picture like that here, and I know, let's say, I know this one angle here, I know this angle right here, and I got 6 right here. I can find whatever this is, let's say this is B. I can find what B is by using a trigonometric function. Remember those funny little helpers in our trigonometric functions? So, ka, and toa. How to find a missing angle of a right angle. So let's say I know one acute angle. First, you start off with the triangle sum theorem. Which basically says that all of the angles have to add up to 180. So if it's a right triangle here, and this was, say, 20, all we have to do is you subtract both of the angles from 180 degrees to find the last acute angle measure. 2, if I only see one right angle, but I know the other two side lengths, so I know I have a right angle, I don't know what the other angle is, so then we want to find the angles. We want to use the inverse. Use the inverse trigonometric functions based on the sides you know. So you set up, substitute, and solve using the second button on the ratio. So second, and then push in for, say, sine. Instead of getting sine, you'd get the inverse of sine. Okay, so quick tips. You start by writing out all the angles and sides you know. First, find the one you know more of sides or angles. Don't forget to check and see how they want answers, rounded or simplified. Remember to set up, substitute, and solve. Then finally, check your answers. All 3 angles should add up to 180 degrees. And your hypotenuse should be the biggest side or the longest side. Remember, 180 degrees and the hypotenuse should be the biggest side is the most important part. So let's try it out. Let's try it out and use our logic, what we have. So solve the triangle, round your answers to the nearest 100th. So here I got an angle, and if I put in angle, this is my opposite, so I'm going to put this as my adjacent, and this will be my hypotenuse, OAH. I have 2 angles already, so I can find the third angle by doing 180 minus 90 and minus 29. 180 minus 90 minus 29, that gives me 61 degrees. So this is 61. That I can solve right away. 61 degrees. Now I want to find the lengths. I already know my opposite length is 18. So I got my opposite. And what else am I missing? I have an angle. I can find, let's label some of this. Let's label this A. So I can find my A. So here, I know so if I have my opposite and my A, I'm dealing with TOA or tangent. So here, the tangent of 29 is my opposite, which is 18, over my adjacent. I'll just call that A. I'll cross multiply A times the tangent of 29 equals 18. A then must equal 18 divided by the tangent of 29, because I divide that on both sides. Put that in the calculator. A then must equal about 32.42 once I put that into 0.47. Once I put that into the calculator. Let's see what we have here to fill in. So I know all the angles. Angle X is 90 degrees. Angle Y is 61. Angle Z is 29. Okay, A is XZ, which is 32.47. XY is 18. So now we're just missing YZ. YZ is my hypotenuse. So if I have my hypotenuse, I can either do my Pythagorean, but I can also do, I got a hypotenuse. I have an opposite. I'm going to use sine. So sine of H, I'm going to call my sine of, my angle H, my sine of 29 must equal my opposite, 18, over H, my hypotenuse. I'm going to cross multiply. So then that means H times sine of 29 must equal 18. H then must equal 18 divided by sine of 29. Put that into the calculator. I get H must equal 37.13. So it's 37.13 for YZ. Let's go down to number 2. Okay, angle E, I can fill that in right away. That's 90 degrees. I don't have any other angles. So I can't just do 180 minus the other two angles if I'm missing the angles. So I'm going to first find a side. I can use my side using my trig function, or I can find an angle using the trig function. So I'm going to use my side, and I'm going to use my Pythagorean theorem. I'm going to call this one A. Well, I'm going to call this one A for my Pythagorean theorem as my adjacent, or A. I'll just call this A. So here, my A squared plus B squared. Call that big A. Big A. A squared plus B squared equals C squared. So this is B. This would be C. So A squared plus 21 squared equals 75 squared. This gives me A squared plus 441 equals 5,625. Subtract 441 from both sides. A squared is equal to 5,184. If I square root both sides, A is then just 72. So this is 72. And so my distance, ED or DE, is 72. CE or EC is 21. And CD is 75. So I'm getting along. All right. I'm going to pick an angle. I'm going to pick angle D. My adjacent is A. my opposite, so let me cross this out. My opposite is going to be 21. I'm going to cross out the C, and this is going to be my H for a hypotenuse. So here I got opposite and I got my hypotenuse, so I'm going to use sine. So my sine of D is equal to 21 over 75. So I just got to find the inverse of sine of D must then equal to the inverse of 21 over 75. Try to make some space here. So then D should equal the inverse sine of 21 over 75. So punch that into the calculator. This gives me D as about 16.26 degrees. So angle D is 16.26 degrees. And now I just got to take 180 minus all of that. So 180 minus 16.26 minus 90. And that will give me angle C. So 180 subtract all of that. That gives me 73.74 degrees. So angle C is 73.74 degrees. Let's go on to number 3. Number 3, I got an angle. I got one side. I can find a third angle like so. So let's say I get this one will be, let's do measure of my angles, all of my angles first. So measure angle, let's do L, measure angle M, and measure angle N. I know L is 52, M is 90, N must then be 180, N must equal, let's not write that down right, let's do here, and N equals 180 minus 52 minus 90, that gives me 38, so measure angle N is 38 degrees. Let's do LM, MN, and LN for their distance. We know that LN is 3. So now we just got to pick one angle. We got an angle. Let's do this as an opposite. This is adjacent, and this is my hypotenuse. So I have a opposite and a hypotenuse. That means I'm going to use sine. So sine of 52 must equal my opposite over my hypotenuse, which is 3, divided by 1. Cross this. My opposite, so this is my opposite, must equal 3 times sine of 52. 3 times sine of 52, well, that is 2.36. So my opposite, which is MN, is 2.36. I can use hypotenuse, Pythagorean theorem now, or I could use another trig function. So I'm going to use cosine. So here I know that cosine of 52 must equal the adjacent over my hypotenuse, which is 3. So if I cross multiply, my adjacent must equal 3 times the cosine of 52, which gives me about, my adjacent should be about 1.85. So this is 1.85.